The next part is taking a look at solving polynomial equations when we have something like this, where we have x to the fourth, that power is greater than 2, and we don't have a GCF. So the first thing I want to do is look at the fact that this is nice in that it's x to the fourth, and we can break that apart easily. And being that that's the case, that we can break it up into x squared and x squared, then I want to take a look at multiplying two numbers together to get positive 3, but adding to get negative 4. And so I know both my numbers need to be negative, and 3 is prime, so I know that it's going to be negative 3 times negative 1, because negative 3 plus negative 1 is negative 4. So then I can stick my minus 3 and my minus 1 in here, and being that this is equal to 0, I know that that means that either x squared minus 3 equals 0 or x squared minus 1 equals 0. Solving these, I add 3 to both sides and I get x squared equals 3 and x squared equals 1. When I square root both sides on these, I get x equal to plus or minus the square root of 3, because that's not pretty. And square root of 1 is plus and minus 1, so I'm going to write it as 1 and negative 1 just because they are real roots. And that would be our solution. So it's really not any different, especially since you already have the factoring skills. The next one, I've got x to the fourth minus 10x squared plus 21 equal to 0. So I need to break up x to the fourth into x squared and x squared. And I know I need to multiply to get 21, add to negative 10. And I know that that's got to be negative 7 and negative 3, because the other factors are 21 and 1, and that won't work. So negative 7 plus negative 3 does give me negative 10. So I have negative 7, negative 3. When I set these equal to 0, x squared minus 7 equal to 0, x squared minus 3 equal to 0. To go ahead and solve these, I get x squared equals 7, x squared equal to 3, square root. And in this case, we don't have any perfect squares, so x is equal to plus or minus the square root of 7, or plus or minus the square root of 3. Moving on to the next example, we have x squared plus 5 times x squared minus 6, and these are both already factored. That's a nice thing. So we will break these up into x squared plus 5 equal to 0, and x squared minus 6 equal to 0. Here I need to subtract 5 from both sides, so we get x squared equal to negative 5. When I square root, I'm square rooting a negative number, which means I know I'm going to have an I in the problem. So therefore, x equals plus or minus I square root of 5, because square root of 5 doesn't have any perfect square factors in it. On the other side, add 6 to both sides, I get x squared equal to 6. Square root both sides, and I get roots of plus or minus the square root of 6.